I'm Barbara Tharp.
And I'm Michael Vu, and we're with Baylor College of Medicine Center for Educational Outreach.
We're here today to share an activity from the My World Teacher's Guide for Water, How do Liquids Behave with You. The activity is aligned to the national science standards, both for the science of inquiry and for physical science. In this activity, students get to look at some of the unique qualities of liquids. They are able to observe and record. They are able to compare and contrast and draw conclusions regarding these liquids. One of the first things you'd like to do when you start teaching about any new topic is ask them what do they already know about that. So first things we want to do is ask them what do they know about liquids. Let them write down at least 5 liquids that they know of, and then give them a little bit of time to think. And then, Michael, what are some of the things they might answer?
Well, kids would mention things like milk, ink, or soda, anything that they're familiar with at home.
Okay, and how might they describe those things?
Wet. Sometimes they'll say cold because lots of the liquids they deal with are refrigerated. They'll say that they're soft because they don't really know the appropriate words to describe liquids.
So, Michael, let's look at some liquids. Let's see what we might find out about liquids. Let's start with, we have one liquid. This is a relatively clear liquid. We have some blue food coloring in it to make it more exciting. Okay, with this liquid, we have this liquid in the container. We have 250 milliliters of this liquid. We're going to take this liquid and we're going to see what happens when we try to pour it from the cylinder into the graduated cylinder. Michael, what's happening to the liquid?
Well, it's flowing, so it's moving very easily from this container to the graduated cylinder.
Okay, very good. So apparently liquids usually flow, right?
Yes.
Okay, another thing is I had 250 milliliters. I still have 250 milliliters. So what about the volume? The volume stays?
It's absolutely the same. So you started with 250, you ended with 250. The only difference here is it's shaped differently.
Very good. So it takes the shape of the container or is bound by the container, right?
That's right.
Okay, now I'm going to put this liquid back in the beaker. Another important property of liquid is that the liquid, you can take a solid through the liquid. Now, you can't take a solid through a solid, obviously, but you can take a solid through a liquid. Okay? This is another important.
Which makes it very easy to go swimming.
Very good, very good. Okay, what else, Michael? What happens if I take and I introduce energy or heat into this liquid?
Well, 2 things could happen. If you add lots of energy or heat, then you'll have a change of state and the liquid will change into a gas.
Okay, so we have a change of state from liquid to gas, but what happens if I cool this liquid?
And it'll actually get much colder and become a solid.
At some point.
And the spoon would no longer be able to go through it.
Because it was a solid. So then we have 3 different states of matter right here, and the properties of one of those states, the liquid state. Okay, we're going to go ahead and get ready to observe some liquids, some mystery liquids, but before we do, we need materials. Michael, what materials might we need?
Well, we're going to need, for a group of 4 students, several objects. And we're going to start off with hand lenses or magnifying lenses to help students observe things better. We also have 2 liquids we're going to be working with today, liquid 1 and liquid 2. We're going to call them our mystery liquids. We don't know, or the students won't know what they are. We also have a 3rd liquid today, and this is just diluted food coloring. We have 2 types of droppers, and these droppers are going to be used with liquid 1 and liquid 2, and we want to make sure that they're not cross-contaminated, so we'll keep one type of dropper with liquid 1 and another type of dropper with liquid 2. Another tool we'll be using today is a set of toothpicks. We want the students to have 2 each. These are colored party picks. And this is a large sheet of graph paper that's been cut into 4 pieces so that each student in the group will have one of their own. And we also cut 4 pieces of wax paper to cover each piece of graph paper.
Okay, Michael, it looks like we've got plenty of materials, and what we want to do is each group of 4 students would want to have this whole setup. They'll be able to share some materials, but they also need to have some materials that are just for them to use, as Michael said. Are we ready to begin now, Michael?
Well, not quite. Anytime we do an investigation or experiment, we always want to take into consideration safety. Always follow the district guidelines, first and foremost. But with this particular activity, we want to make sure that students do not eat or taste or smell any of the liquids and solids that we have on our table. We also want to make sure that we're dealing with food coloring, and since we're dealing with food coloring, we want to make sure that students are aware of staining the equipment, the surface, or their hands and clothes.
Or you could look like this.
And what we're going to do is we're going to place, to cover our surface, just a piece of newspaper so that if we do have any spills, it'll be contained on this
And
paper.
if they don't have lab tables, it's always good to use the paper. With lab tables, it's not as necessary. Now are we ready to get started, Michael?
I think so. We're ready to start our experiment now that we know how to stay safe.
Okay. Now, you want to begin by explaining to the students how to use a dropper. A dropper is considered in elementary school a tool of science, and obviously they're not going to know how to use it in the beginning. They might have seen them around, they might have seen them for something they've done at home, like maybe drops, ear drops or whatever, but you need to let them practice. One of the most important parts of any science lesson is letting them get familiar with the tools that they're going to be using. So I always demonstrate, and I'm going to use Liquid One to demonstrate, and I'm going to push in on the top and then let it suck up. So then now I've got this Liquid One, in the dropper. I take that, and you may use an overhead projector and show them on the overhead projector. If you do it with an overhead projector, you don't need to cover it. Just make sure that you put the drops near the center of the overhead projector. Otherwise, if you're showing them some other way, you want to make nice size drops and demonstrate that you don't drop it from here, but you drop it close, within about a centimeter or less from the surface. You ask them to make a number of drops. Now, how do we control that? One nice way to do that is to have, as Michael said, the graph paper. You use the graph paper, you put the wax paper over it, and then you ask them to make the drops about the size of each of the grids in the graph. This way they have control and you can see what they're doing. Now, Michael, have I missed anything on getting them started?
No, I think it's perfect. I think we're ready to start.
Okay, well, let's look at the student sheet. We need to look at what are they going to do with the drops? To begin with, Michael, what's the first thing they're going to do?
Well, we're going to have the students do several things. We're going to be working with Liquid One to begin with, and what we're going to have the students do is we're going to ask them to create a drop on their wax paper, and they're going to make a couple observations. The first observation we're going to have them do is look from the top, or a bird's eye view. So we'd have the students stand up and look down. We'd ask them to record it on their student sheet, and then the next thing we would have them to do is to observe it from the side. And the best way to do that is to have the kids get eye level with the table. And so you want to get down and look at the shape of the drop. They can use a hand lens to get a better idea of what it looks like up close. And again, we'll have them draw that. After they do that, we want them to record 3 words that describe the shape or the properties or traits of this drop. After we do that, we're going to ask them to take one of their toothpicks, and we're going to ask them to split the drop. So, taking that toothpick, it's going to be a little hard. If you try to cut it like a knife, it may not work. But if you do it just right, you'll get 2 or several distinct drops. And we'll ask them to draw that as well. Once they've been able to split the drop, we're going to ask them to take the 2 drops and join them back together, just like I did. And as you can see, we ended up with a drop that looked just like the one we started with. We'll ask them to draw that again. The next thing we're going to have them do is we're going to have them take a toothpick and place it into our food coloring container and dip it back into the drop. Now, if we look very closely, the drop goes from clear to the color of the food coloring. It turns blue, and it's very even and nice and blue.
Okay, Michael, let's go ahead now, and what let's do is let's go ahead and let's try both of these liquids. And I'm going to take Liquid One, you take Liquid Two, and let's see what happens and see if we can figure out why it's happening.
Absolutely.
Okay, so let's clean off our wax paper. Okay, I'm going to do Liquid One, you're going to do Liquid Two. Are you ready?
Absolutely. So we'll start off with the bird's eye view, the top view.
Okay, as you said earlier, mine is quite round, domed, transparent. It's standing up very, very tall.
Mine is also round. It's transparent, but it's not domed. So if I look from the side, it's much flatter.
Okay, you might say that mine has some kind of a cohesiveness. What do you think's happening there?
Well, if we think about liquids as matter, every type of matter is composed of molecules. And so if we think about this liquid over here, it's got molecules that are attracted to each other like magnets because they're polarized.
So we have a polar liquid here, which means that it wants to stick together. Now, if I take it, and Michael, let's look at it from the side.
Okay.
Mine is, like you said, we're sticking up really close, really high. It looks like a dome. So the polarity of the molecules is making it stick together. Okay, Michael, what's yours doing?
It's spreading out and laying very flat.
So obviously, liquid 1 is not the same as liquid 2.
They look alike, but they are behaving very differently.
Okay, so what are some words? If I say, okay, mine looks domed, it looks clear, it looks shiny, it looks transparent. Does yours go with all the same words?
Not all of them. It does share some properties that are similar, but definitely the shape is a very big difference.
So mine is
convex.
Mine is convex because it goes out. So we do have a definite difference here. Some similarities, some difference. Let's go ahead. And now we were doing the next part of the treatment with this, and the next part of the treatment was literally separating.
Correct.
We want to make sure that we get a clean toothpick, and we're going to separate. Now, I'm going to make mine into at least 2, if not more.
I'll do the same.
Okay.
I'm not having a whole lot of success.
Okay, I have 2, and now I have 3. How many do you have?
I have 1, and it's one big smear.
Okay, so somehow mine, the way the molecular structure of this liquid works, it's still holding together tight, and it was very difficult to get the pieces apart, the pieces or the drops apart, while Michael's was...
It's just a big blob, unfortunately.
A big blob. Okay, so there's another... characteristic of liquids that they're similar, they both flow, but again, look at this, yours is flowing all over and mine is standing up to some degree.
They're very different.
Okay, so they're very different. Now, if we talk about looking at putting them back together, would yours go back together?
Well, I can push it back together, but it's still one smear.
Okay, and mine goes right back together, and I have one giant drop again. So again, we're looking at cohesion, the way those molecules of water like to stick together. So they're cohesive. Okay, now let's look at what happens with the food coloring. Other than getting it on your fingers, what else can you do with the food coloring?
So
is it going to take it?
You know what? My guess, my prediction, just by looking at these two liquids, and they're very different in their behavior, their properties, is that we're going to have something different, which we do.
Oh, cool. It looks like an eyeball.
It does.
Okay. Is it mixing at all? Can you make it mix?
It is not mixing at all. This blue food coloring is actually staying separate from this liquid.
Okay, and with mine, it doesn't matter how much I put in, it just gets darker and darker because the food coloring is dissolving completely in my liquid. So let's see, what's happening here?
Well, this liquid seems to be a good solvent, and a solvent is anything that allows another type of matter to disperse evenly in it. So the food coloring is very evenly spread out in this drop, whereas in here it's clumped together. So we can say that this liquid 2, does not mix very well with this food coloring.
Okay, so basically, do we know what these liquids are? What do you think, Michael?
I think I know what this one is.
What is it?
I think it's water.
Water. And yours?
And mine, just from looking at it, looks a lot like oil. And I think this is mineral oil.
And you think it's mineral oil because?
It's very clear. If it was vegetable oil, it might be colored.
Okay. So what have we learned about the properties of liquids? And specifically, let's talk about the properties of water. Number 1, water molecules are attracted to each other like magnets, like tiny magnets. Forces of attraction among molecules in most liquids are not as strong as they are, obviously, from looking at liquid 1 and liquid 2. What else, Michael?
Well, and because it has this force of attraction, it allows water to do several things. For one, it allows it to clump to each other and create these dome-shaped droplets. So if you ever drive down a freeway and you see droplets on the car window kind of rolling down and clumping together, that's because of the shape, the molecules of the water.
Okay, and also we noted that water is colorless and transparent, and this is really important, and we can't obviously show you exactly here, but if you think about water and all the plants that grow underwater, because water is clear, photosynthesis can happen underwater. This is another really important characteristic of the fact that water is clear to begin with. And it's an excellent solvent.
Absolutely, and that's really important, especially for living things, because it allows dissolved nutrients to be transported in the cells, as well as removing waste products from cells and tissue.
So water is a good solvent, which is wonderful sometimes, but is it always wonderful?
Unfortunately, sometimes water can also dissolve chemicals or pollutants in our drinking water system. So that can be dangerous to living things.
So it can dissolve just about anything.
That's right.
I think we can call it almost the universal solvent. That's what water is.
That's right.
Now let's look at some extensions. We've learned a lot about the characteristics of liquids, specifically about the important characteristics of water. How can we examine that further? Michael, do we have something we can look at here?
Sure.
Look at this. This is beautiful, but what is it telling us, or what is it doing here? So what do you think we've got here, Michael?
Well, this clear liquid that's floating on the top reminds me a lot of this liquid too. So I'm going to say it's oil.
Very good, that's oil. And the bottom is?
Water, because it has evenly dispersed food coloring in it.
Okay, so it's solid blue, but you don't note that the oil did not take up the food coloring at all. Now, what are we doing with this? Well, this is a good example of an ocean. We have an ocean wave. You can watch the wave just using looking at the oil. You can see the shape of the wave, which is pretty cool, I think. But also you can look that they do not mix. And you can shake it up. Looks like they mix, doesn't it?
And this actually explores another property of these two liquids. So we can also see that oil has a different density than water. And because it has a lighter density, it will float on top.
Because it's less dense, right? Less dense, so it floats on top, and it will spread back out, and we're going to have just clear oil and food coloring in a bit. So let's set that there, and let's talk about another thing you can do with to extend this activity for those kids that are already finished or want to explore further. Is you can look at water races.
Oh, this is my favorite.
Okay, Michael, how does that go?
Well, you can take a drop and form it on a piece of wax paper. And you can take this wax paper and place it over a copy of a maze that you can print out from any kind of source. And taking a toothpick, you can actually have kids race their droplets from one end of the maze to the other end. And you can see, because of, again, that polarity, that attractive force, that droplet is sticking to this toothpick.
Because the toothpick also has water soaked up, so there's water in the toothpick, and that water is, the cohesiveness is making it stick together. That's really cool.
So we've seen a couple of other ways to take properties of water and explore it with kids.
Okay, excellent. Okay, not only will students learn a lot from this activity, but
I think they'll have a lot of fun doing it.